So, good afternoon, everyone. Welcome to the class. So, we'll wait for a while for the students to join in the Zoom as well as the YouTube. Okay. Okay, students. Good afternoon once again. Welcome to the class. I'm Chinmay, and I'll be taking your today's class on circles. So, yeah, in my previous class, we learned about the straight line, right? What properties of straight line, how the equation of straight line is formed, various forms of straight line, angle between the lines, when two lines are parallel, so many things, isn't it? So in our today's class we will learn about circles. Circle is one of the part of conic section. Okay, we'll also see what actually this conic section is, right? And remember, this conic section is one of the very important topic because it has a very high weightage. You can accept minimum 2 to 3 questions in JEE means. So please do concentrate on this chapter. Okay, well then, let's begin. So before that, let me know I'm clearly audible to you all and screen is clearly visible to you all. So please do respond in the chat box so that I can know I'm clearly audible and the screen is visible to you all. I'll be launching and I'm launching the poll for the Zoom people. Please do respond to that. Okay. Well, please do respond to the chat, this thing, chat, technical check. Okay, I can see that everything is clear. All have responded. So I'll be ending the poll right now. Okay, then let's begin with the class. Fine? Well, okay. Mm, fine. So let's see the content of our today's class. So today we're gonna learn about the conic section, some introduction of the conic section, what actually the conic section is. After that, we see general equation of second degree. Then we'll see what actually the circle is, its definition and equation of the circle, and what is the condition on second degree of a second degree equation to be a circle. And after that, we'll see equation of circle in a various form. Okay. So this will be the content of our today's class. So not waiting much. So let's begin with our class. Well, okay. So you can see some images on your screen, right? You can see 3 figures. Tell me, what is the first figure? Yeah. What first figure represents? What's the shape of this figure? It is not. It's a wheel, right? The first figure represents a wheel. So what is the shape of the wheel? Tell me. Answer me in the chat box. Quick. So answer me in the chat box so that the class is interactive. Okay, very good, Yanam JMB. Very good. So yes, this represents a circle, right? Very good. And yeah, now in the second image, you can see a revolution of Earth around the sun. What is the path covered by this Earth? What is the shape of the path covered by this Earth? Yeah? Yes. Very good, Jaimiana. It is nothing but ellipse. And here you can observe a boy throwing a ball. So what is the path covered by the ball? Tell me. The ball is covering one path, some path, right? Yes, yes. Very good, Jaimiana. Yes, very good. It's nothing but parabol. Well, see, in your day-to-day life around you itself, you can see so many shapes, right? Like circle, ellipse, parabola. Have you ever thought what actually these shapes are? How they are actually derived from? Yes? Well, the answer to this question is conic section. Yes. These are the part of the cone, okay? So what are these conic sections? We'll see further. Fine? Well, conic section. Conic section is a shape that results from the intersection of plane and a double right circular cone. Okay, you all know what is double right circular cone. Okay, so this is a double right circular cone. It is known as a right circular cone because from base and the axis, if you consider angle, it will be 90 degree. Okay, this line is known as what? Axis of the cone, and this is the generator. And the angle made by the axis and the generator is known as vertex angle. This is the midpoint. This is nothing but vertex. Okay, this is known as a vertex angle, and I'm representing that vertex angle by alpha. Now, what actually we do here is we cut this cone with one plane. So let me consider this as a plane. Okay, so I'm just cutting it. I cut this cone. When I cut this cone into two parts, here the portion where I cut, there some shape will be formed. Okay, that shape we call it as what? Conic section. So depending on the angle, like if you cut a cone with a different angles, you get a different shapes. And those shapes have different names, okay? So we'll see what are those different conic sections in the next slide. So is it clear to you all what is conic section? Any doubt in this? Well, if there is no doubt, then we'll move ahead. Okay, we'll go to the next one. Well, so now we'll see what will be the angle. Like if we cut conic section with the different angles, what are the, cone with the different angles, what are the conic section you're gonna get? Okay. Now, yes, I already said the angle between the generator and the vertex is what? Vertex angle, and I represented it by alpha. So this is nothing but this alpha. Okay. Now, I consider an angle between the plane and our central axis as what? Beta. Angle between the plane and the central axis is what? Beta. Fine. This is beta. And the angle between the generator and the central axis is what? Alpha. If this both the angles alpha is equal to beta, when we cut that cone with the same angle, then the shape, you can see here, this one, okay, I'll change the color. You can see here the shape, this certain shape is formed here. This shape, we call it as what? Parabola, okay? So we obtain a parabola when the vertex angle and the angle between the plane and the central axis is what? Same. In that case, we will get a parabola. Okay, guys? Well then. So next is this. In this figure, you can see a plane is cutting the cone just perpendicular to our central axis. So angle between this plane and our central axis is what? 90 degree here. And this is our alpha. Fine. So what is here? What is the angle beta here? That is angle between the plane and the central axis. It's 90 degree. When angle between the plane and the central axis is 90 degree, and when we cut that conic section, the shape that we get, see, this is a conic section, we cut it, it will become two parts. The shape that we get here, we call it as what? Circle. Okay, this is nothing but it's a circle. Fine. So next here you can observe this is our angle alpha and this angle beta. Fine. If angle beta is greater than alpha and it should be less than 90 degree. Okay. If this angle between the plane and the central axis is greater than the vertex angle and that beta is less than 90 degree, then the shape that we get, so when we consider that angle and cut the cone, we get two parts and the shape that we get on that cone, that will be what? It will be ellipse. Okay, it will look something like this. When you if you see vertical section of that, so it will look something like this. This will be like circle. This will be ellipse. Here, this shape will look something like this. Okay, fine. Now coming to the next. Here, what we do? Here, this is alpha, and yeah, there's some angle beta here, angle between the this central axis and the plane. That will be what? Beta. If beta is less than alpha, and it should be greater than or equal to 0 degree. Okay. If the angle beta is less than our central vertex angle, and if it is greater than 0, then when we cut with that angle, if we cut our conic section, the shape formed on the conic section, cone, the shape formed on the cone, that will be hyperbola. Okay, that will be hyperbola. Fine. So when you see the horizontal section view of that, you will get something like this. This is the view. Okay, this is how that curve or that conic section will look like, and this is known as what? Hyperbola. Okay, and in our today's class we will learn about what? Circle. Okay, fine. So this will be the hero of our today's class. Fine. So is it clear to you all? Any doubt in this? Any doubt in this? Please reply me in the chat box. Well, if there is no doubt in this, then we'll move ahead. Okay, we'll go to the next one. Okay, very good. Very good, Jaimiana. So we'll go to next one. Next. So here you can observe. Here what we have done, we have represented this conic section geometrically, like how geometrically we can create a conic section, how it looks like and all. How to represent them algebraically? Of course, that question arises, right? So to represent this conic section algebraically in terms of equation, we make use of a second degree equation, okay? The general equation of second degree. So these conic sections are represented by general equation of second degree. The equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 is the general equation of second degree, okay? And it represents a conics, right? Like by conics, it involves like circle, parabola, ellipse, even pair of lines, hyperbola, etc. Okay, so all these things, fine. So this is a general equation of second degree, and we make use of this equation to represent our conics. How do we do it? It's only a single equation, and we have 4 conic sections, right? So what we do is there will be different condition on the coefficient of x and y, okay, of this equation. So depending on that condition, we will get different conic sections. Okay. So we'll see how we will get it and all, right? So let's begin with the next part. So next is circle. Yes. We'll see what actually this circle is. How do we define it? Yeah. A circle is the locus of the point which moves in a plane so that its distance from the fixed point in the plane is always constant. Well, you are coming across the word locus here. We have already learned what is locus in the previous chapter, right? That is straight lines, isn't it? You already learned it. Correct? Tell me, what is the locus? Locus is nothing but it's a group of points which satisfy certain condition, okay? That we call it as a locus. So what is circle? It's a locus of a point. That's group of point which satisfy certain condition. And that condition is its distance, that point that considering its distance from the fixed point in the plane is always constant. So well, I consider this as a fixed point, okay? Let this be a fixed point. I name the coordinate of that fixed point as A and B. Say A is a fixed point. Fine. Then there'll be one more point. I consider this as a locus of a point. H comma K. We know how to form a locus of a given locus of point of a given condition, right? We learned it in the straight line itself. First, what we do? We consider a point H of K, H and K as the coordinate of that point whose locus has to be determined. Okay. Now, what is the condition given to us? Distance between this point and this point is what? Constant. So, distance between these 2 points is what? Constant. Okay. And consider that constant value as what? R. Fine. R. Okay. Now, this H comma K, it lies on the plane. So it can lie everywhere on the plane, right? The same condition if I apply here. So even this point, then it can be H and K. Just start drawing same points on the plane here. With the same condition. The distance is R. Okay, just consider all those points. Consider all those points on the plane whose distance is R from this fixed point A. When you consider these points and when you join those points, you will get one curve, one shape here. Sorry, I'm quite bad at drawing. Just pardon me. Okay, just try to understand the circle. Okay, just join all those points. Okay, all those points. When you join all those points, whatever figure that we get, it will be what? It will be circle. Okay. It's a circle, okay? Just try to understand it. But it's nothing but it's circle. So what is circle? It is a locus of a point whose so that its distance from the fixed point in the plane is always constant. Fine? Okay. Now how to find this distance? Now tell me, how to find distance between 2 points? We have to find distance between A and this point B. How do we do it? Distance formula, correct? So what is the distance formula? Answer me in the chat box. If we apply distance formula to AB, what it will be? It will be H minus A whole square under root plus K minus B whole square, right? So distance between A and B will be under root of H minus A whole square plus K minus B whole square equal to its constant. The constant value is R. Okay. Now what I'm doing? I'm just squaring on both the sides. Fine. When I square on both the sides, what will I get? I will get H minus A square, K minus B square is equal to R square. Now while forming the locus, what we have done? We already applied our mathematical condition. After that, what we done? Over there, we replaced H by X and K by Y to get our equation, right? So just replace H by X and K by Y. What we will get? We will get X minus A whole square plus Y minus B whole square is equal to R square. Okay. So this is nothing but this represents the equation of circle. Okay. Equation of circle with the center A and B. Here center is A comma B and radius is equal to R. Okay. Well, now further let's take this further too. Okay. Yeah. So when center is A comma B and the radius is what? R. What was the equation that we got previously? Sorry, yeah. And this is some point x comma y we consider. So the equation that we got was x minus a whole square plus y minus b whole square is equal to r square, right? Correct? Now just expand this, just expand it, okay? Apply the a minus b whole square formula. We will get x square minus 2ax plus a square plus y square minus 2by plus b square is equal to r square, okay? I'm just rearranging the terms and writing it. X square plus y square minus 2ax minus 2by plus a square plus b square minus, just shift this on other side, equal to 0, okay? We got this. So even this both equations are equivalent, right? This equation 1 and this equation 2 are what? Both are equivalent equations, okay? Now just compare this equation with our general second degree equation. So what is our general second degree equation? Yes. Previously itself we learned it, right? In previous slides that we see. So this is our general second degree equation. I'm just comparing that equation with this equation, okay? So I'll write this equation again here. So what is the general second degree equation? It is ax square plus by square plus 2hxy plus 2gx plus 2fy plus c equal to 0, okay? So this is our what? This is our general second degree equation. Now just comparing 1, 2 and 3, what will I get? Compare the coefficient of x square and y square. It is equal to, both are what? 1, right? Okay. Now next. Now if you compare the coefficient of this x and y, well, there is no term xy in our equation 2. If there is no term, then of course its coefficient will be 0. Leave it. Now compare this coefficient of x and y. You will get 2a minus 2a is equal to what? 2g. So a is equal to what? Minus g. And 2b is equal to what? Minus 2b is equal to 2f. So b is equal to what? Minus f. Fine? Okay. So we know center is nothing but what? A comma b. So here, if I replace these terms, what will be the center? Minus g comma minus f. Okay, fine. Now next, if you compare, you will get c is equal to what? Sorry, a square plus b square minus r square is equal to what? C. Okay, a square plus b square minus r square is equal to c. Fine, you got these values. Now just substitute these values in our equation 2. Okay, just substitute these values in our equation 2. What we will get next? So when we substitute it, we will get, I'll write here, x square plus y square. Here you can observe it is minus 2x. In the place of a, I'm substituting minus g. So it's gonna be plus 2gx plus 2fy plus c equal to 0. What I'm doing, in the place of a square plus b square minus c square, I'm replacing it c. So c equal to 0. So this is nothing but, it's a general second degree equation of circle, okay? It's a second degree equation of what? Circle. This equation represents, I can write it as a general form of circle. Well, what is center here? Center is nothing but minus g comma minus f. Fine. Center is minus g comma minus f. If equation is given in this form, center will be what? Minus of half of the coefficient of x and minus of half of the coefficient of y. Okay. And what is the radius here? Radius is, we know c is equal to a square. Oh, sorry. C is equal to nothing but a square plus b square minus c square, right? R square, sorry. So R will be what? R will be equal to a square plus b square minus c r square. So this implies r is equal to under root of g square plus f square minus c. Okay. Of course, I'm just replacing my a and b with this g and f because our center is a and b. That is nothing but minus g comma minus f, right? So this is. So remember, if this is our general form of the circle, this will be the center, and this represents what? Radius. Okay. Is it clear to you all? Any doubt in this? Tell me. Any doubt in the general form of circle? Please let me know in the chat box if there is any doubt. Even the YouTube people, if you have any doubt. Okay. No doubt, right? It's clear, right? Please answer me in the chat box so that I can, yeah, very good. So if it is clear, we will move ahead. Fine. Okay. Now we'll see what is the condition that should be there on our general form to be a circle. So this is the equation of a circle we got, right? And this, we already know what is general second degree equation. What is that? I'll change the color. That's good. Okay. General second degree equation is ax square plus by square plus 2hxy plus 2gx plus 2fy plus c equal to 0. Now just compare this both. I'll take it as A. I take this equation as B. Just compare A and B. Okay. When you compare A and B, coefficient of what? X square and y square, b square you get what? A is equal to b is equal to 1. Okay. And here you can observe coefficient of xy is 0. So when you compare it, here in our circle equation, coefficient of xy is 0. Coefficient of xy, it is nothing but h, it is equal to 0. So for the given general second degree equation to be circle, these two conditions has to be satisfied. What is that? One is coefficient of x square and y square should be equal to 1. One condition. And the second is coefficient of x and y must be equal to 0. Okay. So this is the condition here. I have put that into the words here. Yeah. So the necessary and sufficient condition for a general equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 to be circle is coefficient of x square and y square should be equal. It should be equal to 1. Okay. Because x square plus y square 2gx plus 2fy equal to 0. What represents equation of circle. Right? And another condition is what? Coefficient of xy should be 0. If these two conditions are satisfied, then we can say that the given general second degree equation represents a circle. Is it clear to you all? When can we say a given second degree equation is a circle? Yeah? Yes? Tell me quickly. Here, in case if it is not like equal to 1, if it is ax square plus ay square something, in that case you can divide the whole equation by a and make it as a 1, okay? That we can do. But we have to make coefficient of x square and y square as 1. Is it clear to you all? Any doubt in this? Yeah? Anything need to be explained? Well, okay then. There's no doubt. Then we'll move ahead. So let me see how much you all have understood this. Here we have a, yeah. Here we have one more concept, that is nature of the circle. We already seen general equation of circle, right? It was given by x square plus y square plus 2gx plus 2fy plus c equal to 0, correct? And we have seen its center is minus g minus f and radius is this. So now we'll see what is the condition on this radius. Like to a given circle to be a real, what the condition is. So we know this is a radius, that is under root g square plus f square minus c. Now, if the value under this root, that is g square plus f square minus c is greater than 0, then the radius of the circle is real. Of course, if under root value is what? Positive, it will have real value roots, right? So the radius of the circle will be what? Real. And hence the circle is also real, okay? So if value under that root is greater than 0, radius will be real. Hence the circle will be real. Now what if it is equal to 0? What if value under that root is equal to 0? If it is equal to 0, radius will be equal to 0, right? Now just imagine if radius is equal to 0, can we like, we can't, there should be some value, right? If radius is 0, it will be like point, just a point, right? You can observe this thing, right? It's just a point. So we call it as what? Point circle. Okay, this value is equal to 0, radius will be 0, and we call that circle as point circle. And when that value is less than 0, what happens? If that value is less than 0, this whole radius becomes what? It's imaginary, right? The radius becomes imaginary. When it's imaginary, we call the circle as imaginary. So, and it is not possible to draw because the radius will be imaginary in that case. Okay. So is it clear to you all what is the nature of the circle depending on the radius? Yeah? Any doubt in this? Well, if it is clear to you all, then we'll move ahead. Okay, we'll go to the next one. Well, next, here's a concept test for you all. Just tell me which among the following represents the circle. Okay, quickly answer me. Yes. So people in the YouTube as well as the people in the Zoom, quickly answer me to this question. Which of the following represents the circle? So options are x square plus 2y square minus x plus 6 is equal to 0. X square minus y square plus x plus y plus 1 equal to 0. Next is x square minus y square minus xy plus y equal to 0. And the next option is 3 into x square plus y square plus 5x plus 1 equal to 0. Answer me. Yeah. Quickly. Let me see how many of you understood. Yes, you'll be getting a time to answer it. What is the condition for a circle, like general second degree equation to be circle? Yes. Okay. Okay, Jamiana. Just check your answer once. Well done. You tried it. But check your answer once. Okay, I'll explain it. See, what is the condition on the second degree equation to be circle? Coefficient of x squared should be equal to coefficient of y squared equal to 1, right? And there's one more condition. Coefficient of x into y will be equal to what? 0. In this equation, let's check what is coefficient of x square and y square. Coefficient of x square is 1 and coefficient of y square is 2. Of course, these both are not equal. So it's not a circle. Clear. It's done. Now, no need to go to second condition only. When first condition is not satisfied, it's done. It's not a circle. And in this case, we also coefficient of x square is 1. Here, coefficient of y square is what? It's minus 1. When you compare it with the general equation, it's minus 1. So both are not equal. So of course, it's not a circle. Even in the next case, what is happening here? Here also 1. Well, here x into y, coefficient of xy is 0. I agree. But coefficient of x square and y square are not equal. Remember that. So in this third case, again, coefficient of x square and y square not equal. So done. It's not the option. Now coming to the fourth. So of course, ma'am, that is left out. So of course, that should be an answer. You might say, yeah, of course, it's an answer. But we'll see how actually its answer is. Like how we got it as answer. So now what is happening here? Here we have a coefficient of x square and y square as other than 1, right? So what did I say previously? If it is other than 1, divide it by the number. So divide this equation by 3, you will get x square plus y square plus 5 by 3x plus 1 equal to 0. Okay. Now tell me what is coefficient of x square and y square here? It's 1, 1. Both are equal, right? Correct? And coefficient of x into y is what? It's 0 here. Why? Because we don't have xy term only. There is no xy term. So, of course, its coefficient will be what? 0. Fine. So, that's the reason the fourth option is correct. So, is it clear to you, Janvi Anna? Is it clear this question? The option 4 is correct. Just reply me yes or no. Well, okay then. So if it is clear, yeah, very good. If it is clear, we'll go ahead. We'll go to the next one. So next we'll solve an example, okay. What they're asking, find the center and radius of the circle x square plus y square plus 6s minus 8y plus 9 equal to 0. So quickly do it, try it. So what is general form of our circle? General form of circle is x square plus y square plus 2gx plus 2fy plus c equal to 0. Okay, now just compare 1 and 2. Okay, from 1 and 2, what is g value? Okay, very good, Jane, very good. So g is what? 6 here. F is what? Wait a minute. What is g value? So 2g will be what? 2g will be 6 here, right? So g will be 3. 2f will be what? Minus 8. Okay. F will be minus 4. So just recheck your answer, Jane. So what will be the center here? Center is nothing but minus g minus f, right? So it's gonna be minus 3, 4. Okay. Now coming to the radius. How do we solve radius? Radius is nothing but under root g square plus f square minus c. Correct? Okay, what is c here? C is 9. So this is gonna be what? This is gonna be under root g square, that is 9 plus 16 minus 6. So minus 9, okay? Minus 9. So radius is gonna be what? 4. 4 units. Okay? Well, so this will be our center and radius of our given circle. So is it clear to you all? Is it clear? It's not 6 and minus 8 because when we compare this equation, we will get C. Coefficient of x is what? 2g. Here coefficient of x is 6. So 2g should be equal to 6, right? So g we will get as 3. Similarly, coefficient of y is 2f. Here minus it. So f we get as minus 1. Okay. Is it clear to you all? Any doubt in this? Quickly answer me. Okay. Cool. If there's no doubt, we will move it. We'll go to the next one. Well, now in the previous thing, what we have done, we discussed about the general form of our circle, right? Now we will discuss about the diameter form. Okay. What is this diameter form? When the coefficient of this diameter, end of this diameter, sorry, not coefficient, when the coordinate points of the diameter are given, how to find the equation of the circle? So, okay, we'll see that. I consider this coordinates as what? Sorry, as x1 and y1, okay? I consider it as x1, y1, and this as, you say, this b, this as x2, y2. Well, to derive this equation, we make use of one fact here. What is that? That is a triangle that is subtended in the angle, subtended by a triangle in a semicircle will be 90 degrees, correct? So when we form a triangle here in the semicircle, what this angle will be, tell me? I'm forming a triangle here. I'm just forming a triangle. So what this angle will be? Yeah. This angle sustained by this triangle at C, it will be what? 90 degree, right? It will be 90 degree. Yes, very good. Very good, Jamie. 90 degree. So we make use of this fact and we'll derive it. Now, if this angle is 90 degree, then slope of AC will be perpendicular. So this AC will be perpendicular, not slope. Sorry. Of course, that angle is 90 degree, then AC will be perpendicular to BC, right? Correct? Angle between them is 90, so they both will be perpendicular. So this implies what happens to its slope? When if two lines are perpendicular, what is the condition on the slope? Tell me. Yes. What is the condition on the slope? Quickly tell me. So slope of AC into slope of BC will be what? Equal to -1. This is the condition. When two lines are perpendicular, the product of the slope will be equal to -1. We have learned this. M1 into M2 is equal to -1. Okay. What is slope of AC? Okay. This point coordinate is x comma y because we are considering an arbitrary point. That point is an arbitrary point. It can be anywhere here. Okay. So it's gonna be what? It's gonna be x minus x1. Okay. Let me write it properly. X minus x1. Oh, what I'm writing? Sorry. Okay. Y minus y1 divided by x minus x1 into. It's gonna be just make use of this line. It is y minus y2 divided by x minus x2 equal to -1. Okay, this is the slope of AC and this is the slope of what? BC. Okay, just take a cross product. When you take cross product, we will get y minus y1 into y minus y2 is equal to minus of x minus x1 into x minus x2. Now take all the terms on one side. We will get y minus y1. Okay, sorry. Yeah, y minus y1 into y minus y2 plus x minus x1 into x minus x2 equal to 0. So this equation is nothing but it represents the equation of circle in a diameter form. Okay. Where end of this diameter coordinates of the diameter will be what? X1 y1 and x2 y2. Is it clear to all? Is it clear to you all? Any doubt in this? Clear, right? Okay, then if it is clear, we'll move ahead. We'll go to the next. So there's one example over here. Just look at the example and just tell me what will be the equation. The example says that the intercept on the line y is equal to x by the circle x square plus y square minus 2x is equal to 0 is AB. Find the equation of the circle with AB as a diameter. Well, we know how equation, if this is the coordinate system. Wait. Okay. Let's leave it. So we know equation of y is equal to x, right? Y is equal to x, something like this. This is the equation of a line y is equal to x. And what they're saying, intercept of that, it's intercepting a circle. Okay. Okay. Intercept of this circle on this line is what? AB. This is AB. This is AB. Okay. This is AB. Then they're asking us to find the equation of the circle. How can we do it? Tell me. Okay. If it is intercepting a line, then we can find the point of intersection, right? Yeah. We can find a point of intersection. So consider this as equation 1. This is equation 2. Let's solve 1 and 2. So what we will get when we solve 1 and 2? we will get x square. In the place of y, substitute x. So we will get x square plus x square minus 2x equal to 0. Okay. So this is nothing but 2x square. I take a 2x common. So it's gonna be x minus 1 equal to 0. So x is equal to 0, y is equal to 1. Sorry. X is equal to 1. Okay. Well then, these are the 2 points I get. So when x is equal to 0, what will be y value? Just substitute here. Of course, y is equal to x, right? So y value will be 0. And when x is equal to 1, y will be what? 1. So what are the 2 point of intersection? So this, what are the value of this a and b? This gonna be 0, 0, and this gonna be what? 1, 1. Okay. Now we got the coordinates of the end of this diameters. We can easily say the equation, right? What will be the equation? Tell me. Yes. Equation gonna be x minus, coordinate x coordinate of 1 point, that is 0, into x minus x coordinate of second point, that is 1, correct? Plus y into coordinate of y minus coordinate of 1 point, 0, into y minus 1 equal to 0. Okay. So this represents our what? Equation of circle. So is it clear to you all? Any doubt in this? Yes. Quickly answer me. Any doubt in this? Even the YouTube guys, if you have any doubt, then please let me know. Okay. Please answer me in the chat box, okay, so that I can know if there is no doubt and I can go ahead. Right? Okay. So if no doubt, then we'll move it. Okay. We'll go to the next one. Let's go to the next concept. Yeah. Next is equation of a circle in a parametric form. Yes. Very good. Very good, Teresa. So what is equation of the circle in parametric form? Here, what we do is, usually we represent circle using x, a variable, and y variable, right? Correct. But here in the parametric form, we represent a circle with only one variable. Okay. Here it will be angle theta. Okay. Then hence we call it as, that parameter will be what? Theta. So we call it as a parametric form. For that, what we will do is, we'll consider 1 point on the circle, an arbitrary point. Let's say x comma y. Okay. Now what we will do is, we'll just join the center and the point P. Okay. Just join the center and the point P. Fine. Now draw a perpendicular line from this point P to x-axis. Kind of this. What you will get? You mark it as M. This is O. You will get a triangle OPM, right? You will get a triangle OPM, a right angle triangle OPM. Why? Because this angle is 90. So in the right angle triangle OPM, I am considering radius as what? R. Radius of the circle as what? R. Right? Now, in this triangle, right angle triangle OPM, this angle is theta. So what will be the sine theta? Cos theta is equal to, tell me, cos theta equal to, this is angle theta and the hypotenuse side is R. Adjacent side value is what? Of course, point x comma y, then this is gonna be x, this is gonna be y. So it's gonna be what? Cos theta will be OP by OM, right? Wait, sorry. Sorry. So cos theta will be what? It's gonna be adjacent upon hypotenuse. So OM by OB. So what is OM here? OM is x divided by R. So this implies x is equal to what? R cos theta. Fine? Okay. Next, consider sine theta. When you consider sine theta, what will be the value of sine theta? Opposite upon hypotenuse, right? So what is opposite here? Opposite is PM and hypotenuse side is OP. Correct? PM is what? Y. And the hypotenuse side value is R. So what does it imply? It implies y is equal to R sine theta. Okay? R sine theta. Observe this equation 1 and equation 2. So this 1 and 2 what? They represents equation of circle. represents equation of circle. Okay. It is x value, it is y value. We can say, right? So coordinate of, if you want to represent a coordinate of the point on the circle in the terms of, in a parametric form, then we can represent it as what? R cos theta minus, comma, R sin, okay, R sin theta. Correct? Yeah. So this is the parametric form of the circle. Is it clear to you all? Any doubt in this? Yeah. Quickly tell me, any doubt in this? No doubt? Okay. If there is no doubt, we will go ahead. We'll go to the next one. Okay. Fine. Next is intercepts made by circle on the axis. So what will be the value of that intercept made by the circle on the axis? What actually intercept is? So intercept is that value when a given curve cuts the respective axis. If it cuts the x-axis, we call that as x-intercept value. If it cuts the y-axis, we call it as y-intercept value. Okay. For that, what we will do here is, we will consider a point, these points, okay. I'll just name this point as what? This is LM. So L is x1, comma y1, M is x2, comma, wait a minute. This is y-intercept, right? Sorry. This point is nothing but this is x-intercept because they are cutting x-axis. So this is x-intercept. When it is cutting x-axis, y will be what? 0. Y value will be 0. So coordinate of this I can write as x1, comma 0, and this is x2, comma 0. Similarly, this is y-intercept. So here x value will be 0. Coordinate of this I can write as 0, comma y1, and this is 0, comma y2. Okay. Fine. You should tell me general equation of the circle. What is general equation of circle? We know, right? Equation of circle is x square plus y square plus 2gx plus 2fy plus c equal to 0. Isn't it? Yeah. Now, if you consider a y-intercept, what? X will be what? Equal to 0, right? So what equation will become? Our equation of circle will become? So one will become x square. So y is 0. Sorry. X is 0, right? We are considering y is 0. So it's gonna be y square because x is 0 plus 2gx, even that term, complete term will be 0, plus 2fy plus c equal to 0. Okay. This will be the equation of a circle. Now observe this equation. It's a quadratic equation, right? Correct? It's a quadratic equation. And we know one point. Okay, you will learn this in the quadratic equation. Don't worry. From quadratic equation, we know one thing, that is distance between the two roots will be given by under root of discriminant. Okay. I want to find the y-intercept, right? Y-intercept is nothing but this distance between this point and this point. That is mod y2 minus y1. So this one, distance between these two will be what? It will be nothing but under root of discriminant, okay? D. I write as discriminant, okay? Fine. So what is D here? What is the discriminant of this equation? Y square plus 2 fy, 2fy plus c equal to 0. Yeah. It will be b square, that is 4f square minus 4ac. A is 1, c itself. Okay. So d will be 4f square minus 4c. So what will be under root of c? So that is y2 minus y1. It's gonna be under root of, I'm taking 4 common, f square minus what? C. So it implies, so what does it imply? It implies distance between this point y2 minus y1 equal to 2 under root of f square minus c. Okay. So this represents what? This represents the y-intercept. Okay. Y-intercept value. If you want to find the y-intercept value, then what we have to do? We have to take 2 under root of f square minus c. If we find this, this will give us the value of y-intercept. So is it clear to you all? Is it clear? Okay. Well then, if this is clear, we'll go ahead. Okay, next one. Next, we have to find x-intercept also, right? So in the case of x-intercept, what will be the y value? X-intercept means the curve is cutting x-axis. When it is cutting x-axis, y will be 0. Correct? So in the case of x-intercept, y will be what? 0. Okay. Therefore, equation 1 becomes, equation 1 is general equation of circle. So this is the equation 1. Okay. So equation 1 will become what? Here y value will become 0. So we will get x squared plus 2gx plus c equal to 0. Okay. This is again a quadratic equation. Now we have to find a y-intercept, that is x2 minus x1. So it's gonna be what? Under root of this discriminant. Okay. Fine. And take this as 1. So there's no confusion. So what will be the discriminant here? D2. Of course, just observe this equation, x squared plus 2gx plus c. Here b value is what? We know standard equation of quadratic equation is ax squared plus bx plus c. Standard quadratic equation. I'm comparing this two and I'm writing. So b will be what? 2g. So b square. So it's gonna be b square minus 4. A is 1, then c. So mod of x2 minus x1 will be what? It's gonna be under root of 4g square minus 4c. So this is gonna be 2 root g square minus c. Okay. So this equation, it represents the y, so x-intercept. Okay. This represents the x-intercept. So is it clear to you all how we got a y-intercept and x-intercept? Any doubt in this? Yeah? Any doubt? Okay, if there is no doubt, then cool, well and good. If it is no doubt, we'll move ahead. Okay, we'll go to the next part. Next, quickly we'll wind up. We'll solve one example and wait. Okay. So given the circle is x square minus y square plus 6x minus 2y plus 4 equal to 0, find the intercept made by it on the coordinate axis. Well, we have a standard equation of circle with us, and using that we have to find what? Intercepts. We know what is, okay, just comparing this with our standard equation, that is x square plus y square plus 2gx plus 2fy plus c equal to 0. So tell me what is g value here quickly. Answer me in the chat box. What is g value? What is f value? And what is c value? Yeah. Compare the equation and answer me give me the value of g, f, c. So when you compare these two equations, what will you get? Just compare coefficient of x with x here. These two. What will be the g value? So g value will be, yeah, it will be 3, right? And what will be the f value? F value will be minus 1, right? And c value will be what? 4. We know what is x-intercept is. X-intercept is nothing but x2 minus x1. It will be equal to what? Under root g square minus c. 2 into g square minus c, right? So 2 into, what is g square? That is 3 square. C is what? 4. So 2 into under root 9 minus 4, that is root 5. So this is our x-intercept. Now we'll find y-intercept. So y-intercept. Tell me the answer of y-intercept in the chat box quickly. Let me know. You people people find me the y-intercept quickly. So it is nothing but under root of 2 f square minus c, right? That is nothing but 2 into under root of, what is f? F is minus 1 square. 1 minus, what is c? Minus 2. What am I getting here? I am getting 2 under root of minus 3. Observe here, what is happening? I am getting an imaginary term here. Imaginary term. It means whenever we get a discriminant as imaginary, the curve never cuts the axis. So it is never cutting the axis means y-intercept doesn't exist. So y-intercept doesn't exist in this case. Okay. So only x-intercept exists and its value is 2, 5. Is it clear to you all? Any doubt? Yeah? Any doubt in this? Well, please answer me in the chat box if there is any doubt. Or just put a message in the chat box. That's more than enough. Okay? Well then, if there is no doubt, then it's fine. So we'll wind up our class here. If you have any doubt even in the previous concept, so you can ask me now. Okay? Anything, you can ask me in the chat box or in the here, even in the YouTube or Zoom one, anywhere. Well, very good. So I'm not getting any replies, so no issues. So if no doubt, we'll wind it up here. So in the next class, what we will do is we will study the, so this is the homework example. This is for the homework. Okay, take a screenshot of this. This question is for homework. Fine. And in the next class, we will see what happens when this circle intersect with the line. What are the conditions, and what is the condition for tangency, family of circle, so many things. Okay. So for today's class, that's all. So we'll meet again. Till then, have a nice day. Bye.